Chapter 25, Problem 22, Holiday and Recknett. We have this figure here, 10 volts. We have the switch on this side. We have capacitor 1, 10 microfarads, capacitor 2, 20 microfarads, and 3, 20 microfarads. We're going to throw this switch to this position, and first we're going to let this capacitor charge, fully charged, then we're going to throw the switch to that position. So the full charge on that capacitor will be 10 volts times the capacitor size, which is 10 microfarads. And this is going to equal 100 microcoulombs. Now that it's charged to 100 microcoulombs, we throw the switch to this side. So we have 100 microcoulombs total to be distributed among these three capacitors. So what we can do is, we know both of these capacitors are 20. So we have 10, and we turn that 20 capacitor into a single capacitor. 20 plus 20 is 40 because they're in parallel, and this one would be 10. So we have to divide 100 coulombs between a capacitor of 10 and the two capacitors of 40. Well, you can look at it, this is a 4-to-1 ratio, which means that this 100 is divided into 5 parts. So 5 into 100, we know is 20. So we got a 4-to-1 ratio. So 4 times 20 is going to put 80 microcoulombs on this side and 20 microcoulombs for C1. And that's the answer we want. The book C1 is equal to 20 microcoulombs. Charge is conserved. This is why we can do this. And we know we just want to distribute this charge among these capacitors. You can look at these capacitors and you know that electrons like to spread out as far away from each other as possible. So that's what they're doing with these capacitors. So this plate and this plate of this capacitor is, each one is 2 times larger than C1. So you can see the 4-to-1 ratio right away. So the answer to this problem is 20 microcoulombs. It's fairly straightforward. So that's the answer.